Hey there, everyone! Welcome back to our channel. If you're passionate about artificial intelligence, or just curious about how these smart systems work, you've landed in the right spot. Today, we're diving into an intriguing concept called semantic memory in AI agents. So, whether you're a tech enthusiast, a student, or just someone who wants to understand AI better, stick around. We're going to unpack what semantic memory is, how it works in AI, and why it matters in the world of intelligent agents. Now, before we jump into the details, let me ask you this. Have you ever wondered how AI systems like chatbots or virtual assistants seem to understand context and meaning in conversations? What's the secret sauce that allows them to pull from a vast pool of knowledge? Well, the answer lies in something called semantic memory. Let's dig deeper. First off, let's define what semantic memory is. In the context of AI, semantic memory refers to the way an agent stores, retrieves, and understands information about the world. It's not just about remembering facts, but also about understanding the relationships between those facts, similar to how humans store knowledge. Think about how you remember your friend's birthday. You don't just memorize the date, you associate it with your friend, perhaps recalling shared memories or the context of when you first met. This associative knowledge is what makes semantic memory so powerful. In AI, we can represent semantic memory through various structures such as ontologies, knowledge graphs, and semantic networks. Let's break these down a bit. 1. Ontologies. These are structured frameworks that help AI understand the relationships between different concepts. For example, consider an ontology for animals. It might categorize animals into groups like mammals, reptiles, and birds, and then provide details about each type, like their habitats and behaviors. 2. Knowledge graphs. These are networks of interconnected information. Imagine a web where each node represents a piece of information, like cats linked to mammals, which is also linked to fur and pets. This structure allows AI agents to navigate and retrieve information efficiently, similar to how we might recall facts based on related knowledge. 3. Semantic networks. These are a bit more straightforward and represent knowledge in a graph format where nodes represent concepts and edges show the relationships between them. For instance, in a semantic network, you might have Paris linked to France and Eiffel Tower. This helps the AI understand not just what these concepts are, but how they relate to one another. Now, let's look at a practical example. Imagine you're chatting with a virtual assistant like Siri or Google Assistant. When you ask, "What's the capital of France?" the assistant doesn't just pull up a random fact. Instead, it uses its semantic memory to understand that capital relates specifically to cities and that France is a country. This understanding allows the AI to provide a relevant answer, Paris, because it recognizes the relationship between the concepts involved. But it doesn't stop there. If you follow up with, "Tell me more about Paris," the AI can pull from its semantic memory to offer details about tourist attractions, historical facts, or even current events in the city. This capability to connect dots and provide context is what makes interactions with AI feel more natural and intuitive. Semantic memory isn't limited to chatbots, though. It's also vital in many other AI applications like recommendation systems. Think of Netflix or Spotify. These platforms use semantic memory to understand your preferences and suggest movies or music based on genres, themes, or similar user behavior. Search engines. When you type in a query, search engines leverage semantic memory to interpret the intention behind your words, delivering results that are contextually relevant rather than just matching keywords. Healthcare AI. In medical applications, AI can analyze patient data and research, using semantic memory to identify patterns or suggest treatments based on a patient's unique symptoms and history. So, to wrap things up, Semantic memory is a crucial component of AI that helps these systems understand and process information in a way that mirrors human cognition. By utilizing structures like ontologies, knowledge graphs, and semantic networks, AI agents can provide contextually relevant and meaningful interactions. Understanding semantic memory is not just about how AI works. It's about recognizing the potential for these technologies to enhance our daily lives, making them more interactive and responsive to our needs. If you found this video helpful, don't forget to give it a thumbs up, subscribe to our channel, and hit that notification bell for more exciting content on AI and technology. And feel free to share your thoughts or questions about semantic memory in the comments below. We love hearing from you. Thanks for watching, and until next time, keep exploring the fascinating world of AI.